Okay, so the problem is the following, that we have this data set. Okay, the data set that I will paste on the screen right now. Okay, so now the aim, the statistics, this is the data we have. The aim is to get a single estimate or an interval estimator of this data. Okay, of the best timing that we should decide. Okay, this is a very natural real life problem that we just discovered. Okay, so it's a very important problem. So you have 6 over here, you have 4 over here, you have 7 over here. So now what I did initially, so I think that other student, I forgot her name, I think she was, I forgot her name, but yeah, she told me that I took the mean. Okay, I took the mean assuming it was normal distribution, which is not normal. You can easily understand from here it's not normal. Let me draw the picture. Like 6 over here, 4 over here, 7 over here, and then 11 over here, then again 6 over here, and then 10 over here. So this is a data like diagram. Okay, this is a diagram we have now in front of us. Okay, so now the question is that what is the best timing? This is 6, this is 6.5, this is 7, this is 7.5. Okay, I'm doing some mistake, surely. 6.5, 7. Oh, I didn't give any 7.5. That is a big mistake. Or maybe I gave, there was no such. Did I give 7.7, guys? 7.5? I didn't give 7.5, maybe. And then we have 6 again. And then we have 10. So 7.5 none, 8, 8.5, 9. So the question is here to understand what is the best estimate that we should use. Okay. So I initially did mean. Guys, what did the mean come out to? Mean kya tha?
One issue, you gave 7. There is no data for 7. There is no data for 7. There is data for 7.5.
Oh, I didn't give. There was no 7.
I think so, but I mean, I'm not sure of that. But as of the data we have right now,
There is no
there is
7.
no
7.5.
7. Yeah.
Oh, okay. There is
Yeah,
no
yeah.
7, but I have 7. Okay, yeah. Just give me my mistake. My mistake. So there is no 7. We have 7.5. Maybe I didn't give 7.5. I'm so sorry about that. Okay. Yeah. Thanks. Yeah. So this is the idea. Abhi bolo. So what is a good estimate? So this is sort of the, if you just draw the kernel density, the kernel density will come out like this. Okay, let me draw the kernel density in R. Oh, no, let me share my screen entirely. If you have drawn the kernel density, just let me know. This is the okay. So this is R. So what was the data? Can someone repeat? 6 कितना है? Can someone tell me how many 6 are there? हाँ. 6. Okay. 6.
Yeah.
7 कितना है? 6.5. I'm so sorry. Let's check A. So it's like I'm replicating 6. Okay, 6 times. That is the meaning. 6.5 कितना है?
4.
4. Okay. C is equal to replication 7. There is no 7, right? 7.5. I think 7 are there. P is equal to replication of 8. Sorry, 7. Okay, 7.5. 8. 8 कितना है? I think 11. Is it? Okay, and replication of 8.5. How many are there?
6, I think.
6. Okay, and 4 F is equal to replication of 9 comma 10. Okay, so it's done. And now we will join it. Data is equal to, okay, let's plot the histogram. I don't know how will it look like. This is a histogram, okay? Okay, I did some mistake. Okay, now 6.6.5 this. You see now, the main problem is if you look into the histogram, you will see that there are multiple modes. Okay, now let's say just for like for 11 and 10, 9 is winning out. So that means the rest of the data is not at all important. That cannot happen, right? This is the problem. Mode is not a good choice. You understand, guys? It's not. It's called robustness in statistics. So let's say just for one moment, here there were, instead of 4, let's say there were 6. It will automatically, you want to see it, it will automatically go up. Don't just, let's say 1%, you see automatically it goes up, okay? So it means now from here it will just shift just because of one or two numbers. This cannot happen, okay? That means this is not robust to the data. Just for 1 or 2%, the entire thing will change. This is not done, right? Do you think it's done? Do you think it's a good voting system for our numerical data? For categorical
No.
data, we cannot do it any other way. For let's say you are like we are selecting the president or the president of the whole university, say, of the, or maybe the class representative of the whole university. We are voting. That's a categorical variable. Each human is a categorical variable. Okay, so we cannot do other than voting system. But in numerical variable, we can do something other than voting, right? Because we have the numbers over here. So that's what my claim was. She told I was wrong. I think I was wrong if I consider the MLE actually. Okay, I told you people that I will use the MLE. So that in that sense I was wrong. Yes, but in general the statistical method, what I think is, I think we should have a better argument, and what I think, it's not a mode. Okay, are you convinced that mode is not a good choice? Like if anyone has some other debating reason against it, please tell me. I would like to hear it. Do you think any reason other? My reason is that mode is not a good choice. I think Shrushti asked this question and Shreya also asked this question, that it's not a good choice personally to me because um, the
No,
mode can.
actually, what we were asking was why is it median? Why is median the best choice?
Yeah, I will tell you why is median. Yeah, sure. I rejected mode due to this reason. Okay. Do you have any positive reason with mode? Like you want to keep mode? Any reason? Good reason? I maybe.
No, I thought that mode was skewed, so I rejected that.
Perfect. Okay, so mode is skewed. I also feel that. Any other persons who are in favor of mode, do let me know. Okay, I would like to hear your ideas. Maybe I'm missing something. Okay, so this is why I just rejected mode, because it's a numerical variable. Okay, so why I use mean in the first go? Okay, let's just do kernel density estimation. I just want to show you how does kernel density estimation looks like. This is how it looks like. Okay, so now, if you use MLE over here, it is coming around 8 and this region by kernel density estimation. Okay, but there are two modes over here. This is a big problem. Can we use MLE over here? So this is what I have in my mind. Okay, so we can reduce the bandwidth, you can increase the bandwidth, but we will get the same thing. If we increase the bandwidth, just give me a minute. Let me increase the bandwidth. Let's see what we can do. To 1 if I keep it. I didn't need a spelling mistake. Ah, yeah. Did something wrong. Okay, anyways, I will just look into it. But yeah, the main idea is okay. So I rejected mode in this due to this reason. The reason, the what I can select now is median. Why I selected median is the following reason is that median tells that above this point more than 50% is having a um, like what I mean is that above this point more than 50% is having a better estimate. I think median may not be a good choice because median is robust over here. Okay, so if you add 1 or 2 6, it will not change. It will be 8 only if you just check it out. That's why I selected median. I wanted a robust estimator. Okay, that means that will not change easily. Median is a robust estimator. Okay, so if you learn statistics, robust statistics, there is a subject in a master's, or maybe if you can research over it, there is median is a robust estimator. It's a robust central tendency value. So that's why I selected median. Mean I didn't select. Mean can also be selected over here, but I think one single number will not do it. I think we can do many more numbers. Now I want to get your ideas. So someone told me this interesting idea that someone told me that since we have got this, okay, there is a it's skewed over here. Okay, I think yes. So this was the data. So someone told me since these two are the top, we can take 830, right? Someone told me this, right, guys? Someone told me about this, right?
Yeah, that is what I had thought, which is why I said 830.
So, but if we are taking that, we are sort of rejecting this region, right? Which is over like 4 plus 6 plus 7, I think over 17 by 44. What is that? 39%. Okay, we are rejecting there,
Yeah.
yeah, which is not done. Yeah.
I realized that once you pointed it out.
Yes. So, what do you think is a good estimator? Mean is a good estimator? Yeah. What do you think? This is a real life problem given to you. Think about it. And there is no correct or wrong answer. You have to just convince someone this is the correct one. Like you think it is like among all the various debates, one will select the best one with the best like intuition. So understand if we combine for A, B, and C over here, A, B over here, it's coming out to be the same level as 8 and 9 individually. Okay, if I combine the 6 and 6.5 to combine it to 6.25, then it will give 10, which is as the same around 8 and 9. So what will we do over here?
I told that 730 to 830 because the kernel density function is increasing very rapidly after 7.
Okay,
So
let's check it out.
time availability is increasing after 7.
Okay, let's check it out. Yeah, please give in the ideas, okay, because these are really important. I can be so wrong with my ideas. Okay, now you see there is a difference. It was 6, therefore it was a difference. Now it's a difference. The kernel density is different over here now. So if you see the kernel density, there are two modes over here. Now this is here mode cannot be used even. Like this too cannot be rejected. Now what do you think? So tell me what can be a good interval? Like what can be a good interval for this? What can be a good interval for this? Any ideas? Let's check mean. What is the mean? The mean if the data is this median यहाँ पर होता है क्या? I don't know.
Actually, I think the data is wrong. The frequency of 6 is 6 and frequency of 6.5 is 4.
Oh, okay. I'm so sorry. Thank you. Okay, so let's again do kernel density. Plot. Yeah, same idea is coming. It must come because here if it was a bit, yeah. here it was coming together. See, there the bandwidth was more, here the bandwidth is less, because to identify these two modes, this bandwidth is becoming less. In that bandwidth is how much bandwidth you're taking, okay? To like how much you're combining together. It's like a sort of the length. So here it's distinguishing between 8 and 9, which is sensible enough. So yeah, tell me, what do you think is a good estimate now? So we are having median as, can we search mode of the data? I think yes. No, mode of. Okay. So yeah, mode we can understand from here. It's 8. So 8 is mode. 8 is okay. What did we get? The mean median. So mean. Okay, okay. So mean is this. Median is 8. Mean is 7.8. Median is 8, and mode is 8. So all of them are coming around 8. So you think 8 is a good choice? These are the basic descriptive statistics you have in your syllabus, okay? Just for syllabus perspective. But for understanding data, what other can you give? But one I didn't really liked, I don't know for the person, name of the person who told that 8 and 9 can be its maximum, so I take the mean of it because it is different from the normal centered tendency, okay? But it makes sense. It makes sense. So, what do you think? Any ideas, guys? Mm. So there is a clustering of people, okay? One cluster of people is going for towards the 6 region, one cluster of people is going towards the 8 to 9 region, okay? The two classes, this is where the clustering idea in statistics come up, okay? We will learn in future that you can see two distinct clusters. So now the question is that which clusters matter more? Okay. So that's why now this is where the mean comes up. Suppose you want to understand which clusters matter more, the mean here comes up that it's giving weight to each and every one, okay? That's why I think it's a much more robust estimate over here also. The mean is giving a much more robust estimator here also. But here in case of class selection time, 7.8 means I have to start from 8 only, okay? But mean is giving sort of a weight to each of these values. So I personally think that when mean median mode both are mode of same and close towards each other, that's why I think that, you see, in the previous case where I was made wrong, I like due to the MLE, is that there 9 was actually 11 and 8 was actually 10. So they told, like she told that, which was sensible enough for MLE, that 11 is the important stuff. Sorry, since it's more, but it's important. But there at that time, 8 was actually at 6. Okay, so that was the thing, that was the problem. But here, everything is coming out like around 8, which I think is a very. I also expected this timing only, like in terms of statistically. Did you get like any ideas, guys? I would like to get your ideas. Any ideas? What are you thinking? So, if you want to give an interval, how will you give an interval? So when you're taking the mean, you're actually giving whatever weight this must have, you're giving that weight. When you are here selecting, so when you're taking a mean, you are sort of giving a value to each one of the votes, which is why I took the mean, okay? This is the reason exactly why I took the mean. The median I choose because median means 50% of the value is before that. So after that, 51, like more than 50% are there. So this is like, but median cannot be explained easily in this format. Like the best thing will be to select the shortest 95% interval. You understand? The shortest 95% interval. That will be the best estimator, right? That is how you learn, like shortest. So I want to select the shortest interval such that the area under the curve is 0.95. The area under the curve here is 1, right? But I want to find the shortest one, so the area under the curve is 0.95, which is the shortest one. I think it will be coming around this one only. Does it make sense, guys? Now, the shortest one idea, the shortest place, because we're going to get a very close estimator. The shortest one. Any ideas, guys? You're very quiet. Are you confused with the problem? Yeah? Any ideas? Yeah, bolo. Srishti, Srinjoy, Sarvesh, Sriya, Moksha, and Arpan. Any ideas?
It actually makes sense. Taking 95% interval makes sense.
Makes sense?
Yeah.
Sriya, Arpan, others, what are your ideas about this?
I have a doubt that 95% interval will mostly fall around the mode, right?
Yeah. But if there are multiple modes, it can change. Yeah. If there are multiple modes, it can change. So it will give around, I guess. It will include the, I mean, like it will include that 8:30 time also. So yeah, I think I don't know how to calculate this. I have to see how to calculate this here. But yeah, that is the idea. So what do you think is a good time? Give me a good time now based on the data that we have over here. You're future statisticians of the world. So yeah, take your decision.
Makes more sense now.
It makes more sense now.
Yeah. According to me, yes.
What others? What do you think, guys? You must be having some idea, guys. You're dealing with data for a long time. You have to deal with data for the next 3 to 5 years, at least. So from this, you have to decide the region. So we will not be so mathematical to get the region, but there's a well amount percentage over here. Okay, there is well over 0.30 like 30% data over here. Okay, here is more than 70%. There is 30%. Okay, 25%, 30%. Here's 65, 75 to 80%. So this is what 75 to 70 to 75%. So this is what we have.
I'm feeling that those people who are in 25%, they can also be in 75% because there were multiple choice options. I
Yeah,
also give three options.
it's okay, but like we are not collecting that data. Okay, we are collecting the preferred time. Say okay, so this is very important. So there can be multiple choices. So
So my point is that 25% people is ignored. That is not correct because they must be in the 75% also.
yeah, then
As there were
this vote also.
multiple choice
So
questions.
therefore, this vote also only matters now, or maybe like very less number of people over here. So we
Yes,
have two
yes.
options. We can take mean. So these are the idea. We can take mean if you want to include everyone, or we can take not mode, but yeah, not mode actually. What I mean is that we can take. I think mean is a better choice over here because we are giving each value like importance to each of the values over here, and there's a like maybe we take this idea. It's around 6.5, and it's around, let's say the height is maximum around, if you take the mean of it, let's say 8.2 or 3. So if we do 6.5 into 1/4 plus 8.3 into 3/4, so let me calculate in R. What do we get? Like I'm just giving a brief estimate. 6.5 into 0.25 plus what was the idea risk one? 8.3 into 0. It's a very vague estimate, okay? Let's see what it comes up. Oh, perfect. It's coming out to 7.85 only. So what I'm doing over here, I am taking the maximum in this region. I'm taking along almost the basic, like, sort of maximum of this two region, okay? And we are sort of taking, so here is 25% data, here is 75% data. So we take an average of it, okay? This is what exactly 7.85, which is exactly around the mean is coming. So I personally feel that mean is much more robust over here if you want to give importance to each one of the person over here. Okay, that's why I told mean. So now do you have any against this logic, mean logic? See, mode is not a correct option, as you can understand. Okay, like logically, here it's coming out to be the same. But for some reason, say, it was just the opposite diagram, okay? Just the opposite diagram. Then what will you do? Will you just just jump from 8 to 9? No. If you just, so let's say it was just opposite, okay? Let's say it was just opposite. Let me calculate the mean in that case. If it was just the opposite, the mean, it would have been around 8.5. Okay. No, sorry. It will not be 9 actually. It will be around 8.7. I've taken 9 directly. No. So what, in the previous case, I did the following. Here, I did I'll tell you, just give me a minute. What is this happening? So in this case, what I did is that there's around 25%, around 6.5, and there's around this plus this. Okay, so it's 8, it's 9. More over here, so I took around 8.3. Okay, it's a vague estimate. Okay, I'm just giving you a vague estimate. I took this for this set of people. I took 8.3. I took this average, 75%, and for this I took this 6.5, and I took 25% plus 8.3 into 75%. This came around 7.86, which is around the mean. In fact, I'm doing like the mean only, okay? Just giving you logic why mean is the correct one, like according to me. Here again, it's for 6.5, 25%, plus, let's say this just shifts, okay? The 8 goes to 9, like the height of 8 goes to height of 9. So it will just shift just like the similar way. In fact, it will be more towards 8 because 8 is a much more weight on the left hand side. So it will be around 8.5 into 75%. It will be around, so you see, if I calculate this now, it will come around 8.5. Sorry. It will come around 8. If I take 9, I did some mistake in the previous calculation. Even if I take 8, 9 in this case, it come out to be 8.37. Okay, so the 8, around 8 is it's a calculation it's showing. You understand why? If I took the mode here 9, but if you took the average, okay, if you took the average in that case, you will see that it's coming out to be 8, but the mode is coming out to be 9. So there is a difference. You have to understand. So this is the basic idea when you're learning descriptive statistics. To understand, there are 3 distinct estimators, okay? Mean, median, and mode. You have to understand when they're close together, then the estimator is actually correct. When they are varying from each other, you have to understand why it's varying, okay? This is the basic idea. So this is the idea that if 8 and 9 was shifting each other, then the estimate will be 8.3, the mean, and the mode will be 9, which is a 70 minutes, like 0.7 hours. That's a lot of time. Okay, that's why I didn't prefer mode. Here it's not showing why mode is bad. If we just change the 8 and 9, I think it will show why mode is not good over here. That's why I took that one. Okay, that's my logic. Yeah, what do you think, guys? Does it is it logical, guys? Srushti, Srinjoy, Sharvesh, Moksha, Shreya, all the people over here. I can see the name. Arpan. Yeah. What do you think, guys? We're gonna end soon. Bolo.
This makes sense to me.
This makes
Maybe.
logical sense to me. You? Good. What about others?
I think mean is better.
Mean is better now? Yeah?
Yes, mean is better.
Mean is better? Okay, good. What about others? All the budding statisticians. Okay. Okay, so let's not waste your time more. I Let's fix the class time at 8, okay? That's what it comes out to be. Okay. Is it fine with you guys? I have nothing to do. It's only data speaking, okay? So yeah. Okay. Bye bye guys. Nice. Thanks for being a part of this discussion.